false start there. I was having some streaming issues. So I'm going to start again. This section, or this series, is going to be about loops and conditions in Ruby. So loops being the ability to repeat code, and conditions being the ability to control the flow of the application. So in a previous section, or in a previous episode, what we saw was the program was executed line by line all the way until the bottom, which is the same way that you would read text. So Ruby does kind of the same thing. For the most part, it does top to bottom, left to right evaluation of your code. At least that's a reasonable way to think about it. There will be caveats to that. Kind of similar to BODMAS or BIDMAS, or however you learned about mathematical operations and the order that they are evaluated in. But the long story short is that it executes from top to bottom. But this isn't always useful. Sometimes you need to do something a little bit different. Sometimes you need to retry something, or do something again, or go elsewhere in your code and do something completely different, and like stop the flow. And so that's what conditions are for. So before we get into it, I wanted to touch on what happened at the end of the last video. So one of the most important things in programming is problem solving, and being able to figure out what went wrong and why. And so what I was hoping, and what I'm hoping, is that at the end of every video, I want to leave you with something that is like, well, why the hell didn't that happen? Or why didn't that work? What's going on? And I'm not going to give you the answer. I don't know the answers to everything. You know, I'm not a Ruby expert. I'm just a practitioner every day. So I don't know everything about the language itself, but the important thing is, when I don't know something, you have to go and you Google it, or you go to forums or blogs or the documentation. Like you need to go and learn and expose yourself to different ways of finding the solutions, or the answers to your questions, because you will inevitably find that you hit a problem and go, I have no idea why this is broken. The code should work and it doesn't, or the flip side of this code does work and it shouldn't, which is actually more terrifying. So that's the hope, that I will leave you every video with something to think about, or something to solve, with some sort of homework, because I could sit here and give you all the answers, or the answers to the things that I'm explaining, but you don't really learn that way. You don't really push yourself and extend yourself. You need to extend yourself. So without harping on that too much more, because it's a little bit ridiculous, let's jump into loops. So we'll go over to IRB, as we have traditionally. It's kind of easy to start that way. Let's create an array of ages that we're going to do some fun and games with. So as we have before, we have 26, 27, 28. We have an array of ages. We're kind of familiar with this from the last episode. It's a list or set of numbers, remembering that it's not actually a mathematical set, because you can have repeats. Or rather, sets are technically something a little different, at least in programming. They are arrays with the constraint that the values must be unique. Anyway, so we have an array of ages, and let's say we want to go in sequence through every value and puts. Remember that puts method? We want to puts it out. So what do we do? There's a couple ways we can do it. There's ways you can do it which are better, and there are ways that you can do it which are not recommended. So I'll show you both. So the first one is actually a little bit magical. So ages dot each, remembering this is a method that we're calling on the ages class, or the instance of the ages. We're calling the each method on an instance of the array class. Ages being an instance of the array class, and we kind of know what methods are. So we can say ages.each, and then we have a little bit of Ruby magic here. So do, and then this is a pipe. If you don't know where that is, it's actually on the same key as backspace. So that's below your backspace key. So or above your enter key usually. So it's along the same line as the QWERTY part of your keyboard. It's probably not something that, if you haven't programmed before, you probably haven't encountered it very often. So pipe, and then what this is saying is, for each value in ages, we want to call that a variable. So or we want to have a variable with that value in it. So what's probably the most sensible name for the variable for each value of an age is age. And then another pipe. Now we press enter. And what this is doing is it's taking us, kind of similar to the class, into some more inline Ruby that we can write, if that makes sense. So we're about to write more Ruby, but it's within the context of what is happening in here. So bringing it back to what we want to do, we want to output every single age in sequence. So we can just do puts age, enter. And similar to class, we use the end keyword to finish it off. Now, different to class is this will execute immediately, because class has no inherent requirement to execute. It doesn't do anything, it just declares things. This is actually telling Ruby, go and run this loop. Go and loop over every single age and output it. So once we type this, what we should see is 26, 27, and 28 down the line. 26, 27, 28. So that's how you loop over an array in Ruby and put the value into a variable, so you can do something with the variable. The do to end section, this do end code is called a block in Ruby. They're basically anonymous pieces of code that run. It's kind of a complicated thing to describe to somebody who's just learning, but essentially it's almost like a mini program that you can give to a method, and that method will execute the block for you and do something with it. So in this case, it's executing this puts age section inside of the each method and exposing this age variable each time. If that's a little confusing to you, don't worry too much about it. Just suffice to say is this is how you would do a for loop for an array. This obviously can be a different variable, and then these two match. So that's what I would say is the recommended way of looping over an array. And here's the way that you do it that I would say is not recommended. So you use the for keyword, age. So this is similar to before. So we're declaring a variable that we want the values to go into, for age in. And we know that the length of ages is 3. It's 3 long, right? There's 3 elements. There's 3 numbers inside of it. So we can go 0, ... and this is some Rubyism, 3, then press enter, then we puts the age out, and then we press it. and then we see here 0, 1, and 2. And why is that? Well, because we're not actually doing anything with the ages. So how do we do something with the ages? So we'll go back and we'll go for age in 0, dot, 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 3. And then we're going to learn something about arrays, which is you can selectively pull certain sections of an array out. So you can go to this element without going to this element first. You can perform operations on different sections of an array with something called indexing. And indexing is basically just a fancy way of giving a number to every single element in the array. And most programming languages you'll find start that number at 0 instead of 1. So this is the first element, but it has an index of 0. You might think that's kind of stupid, but when you start working with programs a little bit more, you'll actually find that it's kind of useful in a way. And there is some debate around this, and as with a lot of things in programming, there's no exact right solution. There's no silver bullet, as it were. But this is the most common idiom, which is why I've been starting with 0 here. You may have noticed that was a little odd. We start with 0, not 1. So let's do some indexing. So we want to index into the array, it's called. So we take ages, and then we say ages, square bracket, I, square bracket. Oh, I forgot puts. Don't forget puts. Now, what this is saying is puts remembering this is a method call, puts the value at index 0 in the ages array. So the value at index 0, remember, is 26. And then as we see here, we would have got 1 for the next one. So the index 1 is 27, and then the index 2 is 28. So we'll execute this code, and what we should see, oh, excuse me, I'm going to make mistakes from time to time. Typing and coding is, talking, coding and typing is a little bit of mental hoops. So we should have been using the age variable here, and end. And we see 26, 27, 28. So that's another way of looping over an array. If that makes more sense to you, I would recommend not doing it anyway, but that's one way. The problem with that is you don't know how many elements you're going to have. There are ways around that. So let's not go into that right now. Let's for the minute though agree that this is the correct or better way of looping over an array. So that's loops. Let's talk a little bit about conditions. So if we want to control how our program proceeds, then sometimes we need to do things based on what the state of the program is at the current time. So if, let's say, you had a program that allowed people to enter a bar, and you're in Australia, you would say, well, if you are 18, then you are allowed to enter the bar, otherwise you are not allowed to enter the bar. So let's work with that. We're working with ages today. Apparently I'm feeling very old. So age is 18, okay? And don't worry too much that we have age here and we have age there. For the minute, that's okay. There are circumstances where you should not do that, and you should be very careful about that. But for the purposes of this demonstration, it's absolutely fine. So we have age is 18. Actually, let's clear the screen. Age is 18. And we have a variable now which contains the number 18. And we want to say if I'm 18, then I can go into the bar, otherwise I cannot. So we use the keyword if, and we've done comparisons before. I believe we did comparisons when we were looking at whether Jason was equal to Bob as instances of the class person. So it's a very similar thing here. If age is equal to 18, and it's very important to note that it's double equals, not single equals. Single equals is assignment, double equals is comparison. So if age is equal to 18, and you press enter, again, we're kind of given this indented block. And then we can say puts, you may enter. And then we can press, well, let's do end first. And we can see here it's immediately executed it and said, well, you may enter because age is 18. And that's great. Now, let's say that you want to do something when that's not true. So you could do this multiple ways. You could say if age, and here's a little bit of a new comparator, is exclamation mark equals, and this is saying not equal. So it's the inverse of the condition that we used to have. If age is not equal to 18, puts you may not enter. And before I type end, have a quick think, what do you think is going to happen? Nothing. Because when we've evaluated this and said, oh, well, age is not equal to 18, in this case, it's not, well, it's not going to do this code because it doesn't go into that condition. And realistically, what this should be, in a bar circumstance, would be less than 18. So if age is less than, where this is the less than operator that you would have seen in mathematics, you may not enter. But this is not really all that useful. Sometimes you want to execute code on both sides. So you want to, if I'm 18 or above, do this, otherwise do that. So this allows us to control more fine-tune how we're doing things. Otherwise, we'd have to do something like this. If age is equal to 18, puts you may enter, and then if age is not equal to 18, puts you may not. And that would run down our application, and that's garbage. You don't want to do things like that. You want to do this instead. So if age is greater than or equal to 18, so again, this is mathematical operations. So if age is 18 or older, puts have a drink. Our bartender is encouraging you to drink, obviously not Australian, given RSA and such. And then we have this else command, so else. This should actually be back a little, but IRB does kind of funky things. So when you press enter, you can then say, let's say puts go home. And then we finally do end, and I want you to think real quick, what's this going to do? Have a drink, because currently age is set to 18. So if we were to change age, then we would expect, if we were to change age lower, then it would say puts go home. It's going to get a little bit annoying to constantly type this, so let's quickly jump into our text editor again. So we'll come out of IRB, clear our terminal, and jump into a text editor. So let's do this. So age is 17. If age is equal to 18, puts come on in, and then again else. And this is how you write code stylistically in Ruby. When you have a condition and you want to do code within that condition, you indent with 2 spaces, not tab, but spaces, 2 space bars. And then when that condition, so the code within that condition has finished, you outdent again. So in this case, back to the kind of start of the line. But you could have something like this, where you would have it, well, it would just outdent 2 lines, not all the way to the start of the line, but let's not do that. So in this case, put go away. And now, let's call this bouncer.rb actually. I'm not doing very well on the typing today. And then remember that we can do this, go away, because we're 17. Now, let's say that we get a group of friends, and we're trying to sneak our mate in to the pub because we're all 18, but he's not. How's that going to look? Let's do a little bit of work with loops and conditions. So ages equals 18, 18, and 17. Now, we want to loop over each person. So the bouncer is going through every person in the group, checking their age and telling them to do something. So how do we do loops again? Ages dot h2 age. And then, well, you remember how I said that you indent things when you're inside of certain blocks? So everything within this, well, actually, let's finish writing it. So it would be this. Let's get rid of this. We will go. Originally, our loop looked like this. So we're just putting the age. But instead of putting the age, we want to do some conditional logic. So we can get rid of that and put our original code in of age checking. And don't forget to indent all of this. So what are we going to expect will happen when we run this code? We'll get come on in, go away. And that's sort of the simplest way of doing conditional logic on loops. And it's not overly complicated. But let's say that if you've got a mate who's 65 in the shade, or mates with the bouncer, or some other kind of condition that isn't just either 18 or not. So let's say let's do this as America. The difference between America and Australia. So if age is greater than or equal to 21, puts come on in, you're American. Oops. And this is where it's important to note that when you have single quotes and you use a single quote inside of the string, it will actually tell Ruby, well, that's the end of the string, and that's not what we want. So you can either do something like this, \quote, which says, basically tells Ruby to allow you to put the quote in. It's called escaping. I won't talk too much about that. Or the alternative is, if you really want to use single quotes, you can do something like this and use double quotes instead to wrap the string and say, come on in, you're American. And obviously the same applies here. If you were to use double quotes, it would tell Ruby that the string is ending. So if you needed single quotes and double quotes inside of your string, then you're going to need to start doing things like escaping. Now, what we wanted to do then is say, well, if you're 18, then maybe you're Australian because you're coming into the pub. So, I mean, right now that wouldn't work because you're either 21 or over or you're going away. So we need some kind of extra condition. Now, you might say, well, we can do this. It's 18, puts come on in, you're Australian, else puts go away. But what's going to happen here? Have a think about it, and we'll run the code anyway. Come on in, you're American, go away, go away. Come on in, you're Australian, go away, go away. So we've actually told the 18-year-old to go away, and then told him he can come in. So this is kind of wrong. So we actually want that original section of code here to be updated to allow different conditions. So we use something called else if. We can say else if age is equal to 18. And get rid of this code that we don't need. Coming in, you're Australian. So when we run this, we should see coming in, you're American, coming in, you're Australian, and then go away. And that's it. That's else if. And you can have else ifs a bunch of times. So 16, you can put in, and then say you're 16. Whoops. And you can run it down as much as you want. There are other control mechanisms for this, but for the minute, let's run with this. The other control mechanism that you might want to look into is called case, and you can do a little bit different mechanisms with case. It allows you to do things slightly differently, but it has a very similar outcome. So that's pretty much loops and conditions. Now let's learn a little bit about what else you can do with looping and arrays in Ruby. And this is where I want to start introducing you to documentation, because you should be reading documentation as you learn things. It is really quite good in Ruby. You have fantastic documentation. So I want to introduce you to something called enumerable. And what enumerable is, spelled like this, it is a piece of code that the class array has within the class. So it's a bunch of methods that are defined on an array that allow us to do certain things with an array instance. And what do I mean by that? So let's have a look. Well, in fact, we already have used an enumerable method, and each is an enumerable method. So the enumerable piece of code that is inside of array defines a method called each that allows you to do something. Or rather, yes, yeah, that's sufficient. It's not strictly true. You're actually meant to define the each method for enumerable to work, but let's not get too detailed. So what other things can you do? So common operations that you'll want to be doing when you're programming with arrays and lists and stuff like that is you'll want to change values of all of the things in the array. So you might want to do something like, going back to our have birthday method from the last episode, you might want to make everybody get 1 age older. So we can do something like this. New ages equals ages dot map. And map is a method that basically says take every single value inside of the array and allow me to do the following operation and then give it back to me in the form of an array. So let's do it like this. Age plus 1 end. So take a guess what this is going to do. Let's run it. Well, not a whole lot of anything, because we haven't put anything out. So let's put new ages now. 22, 19, 17, and 18. So 22's plus 1, 19, 17, 18. They're all plus 1. Okay? So that's how you use maps. And that's particularly useful. It's very, very useful in programming when you need to do mass changes to certain things. And so it's taking an array and giving you back another array with this code having run against every single element in the array. We can also do things like select. So if we want to do a little bit more fancy bouncering, we could say allowed entrance. And we can use the select method. And we can say, what the select method does is it says, for every element in the array, if it meets some condition, then put it into the allowed entrance array that is returned by this method. So our bouncer is going to let anybody over 18 into the bar. So if age is greater than or equal to 18, and then we put allowed entrance, and what we should get is 21 and 18. So what it does is it selects every value from in here, and if it matches this, so if this evaluates to true, remembering that we've done conditionals before, so that it's that true class, that boolean, then it puts that value into allowed entrance. And then we want to do something a little bit more different. Maybe we could reject things. So reject being the same as select. Less than 18. So we could have disallowed entrance and puts disallowed entrance. Excuse me? Ages reject. Age less than 18. Oh yes, sorry, excuse me, it's rejecting those values. So the condition actually stays the same. Sorry, again, the talking and the typing and all such, it can do your head in a little bit. So it rejects if the age is over 18. So I've kind of done this a little bit wonky. It's rejecting the value. We're not rejecting them because of the condition. Like, how do I say this a little bit more clearly? So we are rejecting if this is true. So it was probably not the clearest example to use. But I think you understand how it works now, given that I've shown what happens when you flip the condition and show the output. So the other one that I think is kind of useful is any, and hopefully this will introduce you to another Rubyism using question marks, which is I think it's unique to Ruby, and it's really, really useful. So as an example, let's say we can do this. So we're creating a method. Legal drinking age, actually. This is a much more sensible name for the method. Legal drinking age, question mark, 0. So remembering this is how you index. So what we're doing is we're creating a method with this question mark, and we're just saying, give me this, like, return the evaluation of this condition from this method. So what we should see when we get this back is true, right? And then if we were to say 0, 1, 2, 3, so we take the last element, which is under, we get false. This is a Ruby idiom, or actually it's a Ruby inbuilt that basically says whatever this method is that we're calling, this question mark means that the method should return a true or false. So taking it back to methods being messages or a form of communication, we're asking a question of the method and saying, is this true or not? Or yes or no? Or 0 or 1? And it's a really, really useful thing and way to get people to think about making their programs read more like English, which is very, very useful. One of the best things about Ruby is the community gems, which is the libraries, the code out there that you can use for free, is all very well written and very readable, at least in my opinion, relative to other languages. All of the third-party code is generally very well presented and manicured. So, and I honestly think this is one of the reasons for it. That question mark really makes Ruby quite a readable language. Now, I don't want to harp on too much longer because this has gone on a little while and it's kind of a long episode. So let's finish this off by doing one of the more interesting things. So let's drive home why this is good. So we're going to run this code, and what we see is x is an array of 1, 2, and 3. And we're going to loop over it, and we're going to increase it. So this is, well, let's call them what they are. So we're going to increase everybody's age, and let's actually make them all underage. So we're all about to have a party, and we're all about to go into the pub after that. So I'm feeling very alcoholic today, apparently. It's all pubs and parties and ages. So let's run this code. Ruby ob1.rb. Well, okay, so we've got the I. We haven't changed the I. Let's make this a little bit nicer. Let's try that again. 1, 2, 3, and 4. That doesn't seem right. Why the hell is that? Right. So that's not going to work. So we need to index. So remembering that this is actually this value in sequence. So age is going to equal to age plus 1. Well, then why the hell is this broken? Undefined method plus for nil class. And with that, I will leave you to figure it out.